No,
No,
sir.
sir.
No.
No, sir.
Okay. Okay.
Yes,
Let
sir.
me explain this and then go to family of planes and family of lines. Okay. Family of planes I explained. No, you understood?
Yes, sir.
Yes. Similarly, family of lines, I will explain. Just remind me after this. So here we started with this plane, ACB plane, 111 plane, and from point O we draw a line or drop a line at point P. So this OP is perpendicular to this plane, and we call this OP as interplane or distance. That means there should be a plane at O, parallel plane at O. We'll check how it works out and or how that plane has to be at O. Okay, just yeah. We'll take this. All of you mute your microphones. Give me a second. We'll take this. We'll take two planes here. Okay, we'll take two planes here. Let us take this as origin. Okay, this origin as plane at 111 plane. That is x-axis here 1, y-axis 1, z-axis 1. So these are the 3 points 1, 1, 1. So let's connect this point. This is one plane. Somebody's microphone is still on. Please mute it. Okay, this is one plane. Next, let us take another parallel plane. Okay, so let us consider this as origin. This as origin. This is 1A, 1B, and 1C. Okay.
Excuse me, sir.
Yes,
You can mute everybody, sir, because you're the presenter. So you
I
can do.
know, but I am in the presentation mode. I have to get back and mute them and again come back. That's why I asked you to mute. Right?
Okay, sir.
See, I have to just a minute. I have to go out of this presentation now. Then I have to take this. Then I have to mute everybody. Here, yeah. Mute all. Then go back. Then start my presentation.
Thank you, sir. No disturbance.
This is the problem. So, okay, this takes a lot of time. I don't want to disturb it. That's why I ask you to mute. That's it. Nothing else. Okay, fine. So now I take another plane with this as origin, this point as origin, and this is 1A, 1B, 1C. Let's connect the dots. This is again 1 plane with respect to this origin. Okay, so this is again a 1 plane. Okay, are these planes parallel to each other? Somebody again unmuted. See, shall I ask? Okay, fine. Are these parallel planes? It's like, let's take this point, this line. Let's take this line. Okay, this line, and let's take this line. This line and this line. There is a line which connects the ends. This diagonal line. Let's draw a diagonal line which connects these two. Simple line. So we have this plane orienting in this direction. That means from this point to this point. Both the planes start from the same line, same baseline, and orient onto this line. There is another plane, which is orienting in the same direction at same angle onto the same line. Now we have to find the distance between these two lines. Planes. Distance between these two planes. It has to be perpendicular distance. So we have to drop a perpendicular between these two planes because they are parallel, and we call this as interplanar distance, DHKL. Now what I have taken is, instead of dropping this perpendicular anywhere between the planes, what I have done is I have taken the end of this plane, this particular point, and from this particular point I have dropped a perpendicular. So this particular point is O. That is here, this is O. Okay, and I have dropped a perpendicular here, that is P. So now this OP represents distance between these two planes. So from here, if I drop a line OP here onto this plane, that OP represents distance between these two planes, the red plane and the green plane, which are parallel to each other. So OP represents these two planes. That means we have a plane at O and we have the other plane which is parallel to that plane. So we take the distance OP, that gives us perpendicular distance or interplanar distance. Do you understand this? Any doubt? If yes, we'll go back to our original diagram or the slide. Is this clear now?
Yes, sir.
Why we took OP as perpendicular distance or the interplanar distance? You don't have to write this. Don't have to write, just remember, that's it. I'll give the slides anyhow. I'll not erase this, I'll give the slides as it is. You don't write this. Okay, you have to write this one. So here we get this, right? So this is the plane. A, B, C is the plane, what we intend, and OP, we have dropped a OP, that is, OP is perpendicular to A, B, C. And from P, three lines run to axis Y, axis X, and axis Z. Right? So these three lines meet the axis at the intersection of the plane itself, because these lines are running on the plane themselves. So angle at P becomes 90 degree, whether it is PC, PB, or PA, it is 90 degree. Okay, so this angle at O and C, at O towards C, the angle becomes theta 1. At O towards B, angle becomes theta 2. At O towards A, angle becomes theta 3. So these are the respective angles made in the triangle OPC, OPB, OPA. Right? So OP acts as common adjacent to three right angle triangles. OP acts as common adjacent to three right angle triangles. Now we can represent OP as OP is adjacent. Okay. PB is opposite. BO is hypotenuse. Similarly, OP is adjacent. PA is opposite. Okay. AO is hypotenuse. Similarly, OP is adjacent, PC is opposite, CO is hypotenuse with the respective angles theta 1, theta 2, theta 3. So we can represent OP as DHKL, X intercept or the intercept on X axis into cos theta 1, Y length or the Y intercept into cos theta 2, Z intercept into cos theta 3. Is this clear?
Yes, sir.
Now, you want to write this down? Have you taken down this diagram?
So just a minute,
Yes,
we are
sir.
just taking it down.
You take down this diagram and let me know. I'll
Yes.
dictate 2-3 sentences so that then we can go here. Okay.
Excuse me, sir.
Yes.
In POB, the hypotenuse is y, sir.
POB, hypotenuse is Y. Yes.
Okay, sir. Sir, all the three angles POB, POC, POA are 90, no, sir?
What is that? P?
POB, POC, and POA are 90 now, sir.
Angles at P with respect to X, Y, Z all are 90 degrees.
Okay, sir.
It's like, let me draw at least one triangle so that you will understand. It's like this. This is P. Okay. This is O. And this is B. Yeah, sorry, wait. Fine, wait. Very good. Just a minute. P is O. This is B. Beta.
Excuse me, sir.
Yes.
Sir, you said that at origin the plane passes through it, no, sir?
That I explained, no? I'll tell it in a sentence. If you have not understood, I'll explain. Otherwise,
No,
if you
sir,
want just a sentence,
but
I'll tell.
whether O is middle of the plane or it is the corner point of the plane, sir?
Corner point of the plane. But
Okay,
that
sir.
plane is not a small plane. It can extend as much as you want.
Okay, sir.
Over.
Sir,
Yes.
sir, in triangle POC, sir, OC is the hypotenuse.
Yes.
Okay, sir.
Will you write down? Consider 111 plane as 111 plane A, B, C as shown in the diagram.
Consider
Consider a plane A, B, C as shown in the diagram. Okay. Consider another parallel plane at O. Consider another parallel plane at O.
So can you tell from first again? Voice breaking.
Consider 111 plane. 111 in a bracket. Consider 111 plane ABC as shown in the diagram. Okay. Consider a parallel plane at O. Parallel means it also has to be 111. Consider a parallel plane at O. Now, the distance between these two planes is the distance between these two planes is represented by OP. OP. Which is called interplanar distance. Which is called interplanar distance. Okay. The line OP is perpendicular to the plane ABC. The line OP is perpendicular to the plane ABC. Okay. Now draw PC, PB, PA onto X, Y and Z axis respectively.
Sir, once again, can you say now draw PCPA, that one?
Draw PC, PB, PA onto the X, Y, Z axis, X, Y, Z, Z, X, Y, Z axis respectively to meet the intercepts of the plane. To meet the intercepts of the plane. That means these lines run on the plane. Okay. Now we have three right angle triangles with OP being common adjacent. Now we have three right angle triangles with OP being common adjacent. With angles theta 1, theta 2, theta 3 respectively along with angles theta 1, theta 2, theta 3 respectively along X, Y,
X, Y, and Z.
yes, and Z axis.
Sir, what is after respectively, sir?
Respectively means theta 1 corresponds to X, theta 2 corresponds
So,
to
sir,
Y.
I'm not
theta
asking meaning, sir. I mean, what is next sentence
X,
after
Y, Z
respect?
axis. X, Y, Z axis. X, Y, and Z axis.
Sir, can you repeat once again? I missed the point.
Where did you miss? You read out because I cannot
Now
construct
we
the
have
same
three right
sentence.
angle triangles with OP being common adjacent.
Okay, OP being common adjacent and theta 1, theta 2, theta 3
Yes, sir.
being angles along XYZ axis. Theta 1, theta 2, theta 3 being angles along XYZ axis.
Thank you, sir.
Okay, fine. So once you understand, you can write down one of the triangles like this. Okay, or all the three, it's left to you. Next, OP, which is equal to DHKL, is equal to X cos theta 1 equal to Y cos theta 2 equal to Z cos theta 3. That means OP can be expressed in terms of X axis and theta 1, Y axis and theta 2, or Z axis theta 3. Write down this. Once you finish this, we have HKL is equal to A by X, B by Y, C by Z. This is from the definition. From definition we have here. Write down. From definition, we have HKL is equal to A by X, B by Y, C by Z. Okay.
Sir, here
Then-
ABC denotes this basis vector, no, sir?
Yes, that is from the definition of the Miller indices.
Okay, sir.
When we do the Miller indices, we discuss no Miller indices HKL is equal to A by X, B by Y, C by Z. Okay. Then we just interchange HKL with ABC. Sorry, XYZ. Then XYZ is equal to A by H, B by K, C by L. Okay. Then we replace this XYZ with A by H, B by K, C by L. Okay.
Sir,
Yes.
the HKL is equal to A by X, B by Y, C by Z. Where did they mention it, sir? That one in the first.
In the what is that Miller indices procedure we discussed, no?
Means you have mentioned that to take reciprocal on that, no, sir?
Yes. First what we expressed, we took intercept X, intercept Y, intercept Z. Okay. Okay.
Yes, sir.
It was X equal to sum of something of A, Y is equal to something of B, Z is equal to something of C. X may be 1A, this may be 2B, this may be infinity C, right?
Yes, sir.
Then we represent it with respect to ABC. Okay.
Yes, sir.
Then we take reciprocal of, right?
Yes, sir.
What do we get?
Oh,
This one.
Okay, sir.
Afterwards,
Okay,
we reduce this. We take LCM and we represent it as integer. Here we have not taken LCM. We are straight away keeping it as it is. It is not yet in the integer form, but it is fine. This is not the final form, but just before the final step. It's fine.
Actually, we
Yeah.
have to take that LCM also, no, sir. XYZ LCM.
If you take LCM, finally you will get HKL. HKL you will get after you taking LCM for these values.
For XYZ, no, sir. LCM.
Yes, you have to take LCM for this, not XYZ. We have to take LCM of A by X, B by Y, C by Z values. Okay.
Oh, okay.
Afterwards
Okay,
only
sir.
you will get HKL. So HKL is
But
equal
you
to
said to take denominators LCM, no, sir.
yes. You have to take, if you want the final integer values, you have to take LCM for these values and reduce it to get the integer values, 3 integer values, so that you get HKL. Okay.
Okay, sir.
Before you reducing, this is the way it is. Okay.
Okay, sir. Thank you, sir.
Fine. So then we can replace or we can interchange HKL with XYZ like this. XYZ is equal to A by scale, the previous or in this equation we substitute x, y and z with what we have got, a by h, b by k, c by l. Then we get this. Okay, next step. We have for orthogonal coordinate systems, right? For orthogonal coordinate system, we have cos square theta 1 plus cos square theta 2. This has to be theta 2. Okay, plus cos square theta 3. This is a mathematics theorem. Cos square theta 1, cos square theta 2 plus cos square theta 3 equal to 1. This is for orthogonal coordinate system. Write down here. For orthogonal coordinate system. For orthogonal, that means three mutually perpendicular coordinate systems. For orthogonal coordinate systems, we have cos square theta 1, cos square theta 2 plus cos square theta 3 equal to 1. Right. Now we have cos theta 1 here, theta 2 here, theta 3 here. We will take that and express d square HKL into h square by a square plus k square by b square plus l square by c square is equal to 1. We have just done cos square theta 1 plus cos square theta 2 plus cos square theta 3. And we get d square HKL into h square by a square plus k square by b square plus l square by c square is equal to 1. Fine.
Yes, sir.
Reducing this further, we get DHKL is equal to 1 over under the root h square by a square plus k square by b square plus l square by c square. Okay. Then for cubic. For cubic. For cubic with its lattice parameters.
Sir, in this, which formula we have to remember, sir,
For
for the
cubic.
main problems?
What is that? I didn't get.
To be equal to C.
For cubic crystals or cubic system, A is equal to B is equal to C. If we put this condition here, further this is reduced to DHKL is equal to A by root of h square plus k square plus l square. DHKL is equal to A divided by h square plus k square plus l square. So this is the equation for cubic crystal. This equation is for cubic crystal. This equation, final equation is for cubic crystal. If it is not cubic, then you will have to use the previous one.
Sir?
Yes, yes.
For examination purpose, we have to remember all these derivations or any one important formula in this?
No, these derivations might be asked because you will have descriptive questions, right? So when you have descriptive questions, derivations would be asked. That's why I'm showing you. Otherwise, I wouldn't have explained in this detail.
Sir, if
this is a very
MCQ,
simple.
Then which?
No MCQs. You will have to write and scan and upload. You will be given the question paper. You will have to write on white sheet with your roll number written legibly. Then scan it with your mobile phone. Then upload it in MS Teams in your group. Your proper groups will be created soon. You will have to upload in MS Teams, and then I'll evaluate it. Unless we meet physically. That is the arrangement. We don't know when we are going to meet physically in this semester or not. We don't know. Let's see.
Sir, mainly
Clear?
if you remember the above formula and the second formula, we can derive now, sir.
Yes, you don't have to remember anything. You just have to write down this diagram. You just write down this diagram. You can easily derive. But you should know the steps, what to do next. That you should know. All that you need is this diagram. That's it. So you have to practice once or twice. You practice, you will get it. It's a very, very simple derivation. Next, you have Schrodinger's equation and continuity equations. Okay, Schrodinger's equation gone. Then continuity equations. It's a nightmare. Remember, it runs into 2-3 pages. Like this, if I have to do, then it may be 5, 7, or 8 slides. Continuity equations.
Is that also mathematical only, no, sir?
Yeah, it is mathematical, but it has a lot of physical significance. So mathematics we will do for 7 to 8 slides continuously. Then in one sentence, I will explain the physics behind it.
Sir.
Yes. Yes.
Sir, for trigonal, it is also na A is equals to B is equals to C, sir.
Where? For yeah.
Trigonal.
Wherever.
But
yeah.
what
Wherever
you said
it
for
no.
Orthogonal coordinate system.
Yes, it works only wherever alpha, beta, gamma are equal to 90. For monoclinic, we cannot take this. This itself will not.
Cubic only.
Yeah, cubic and what are all the other things we have? Alpha, beta, gamma equal to 90 degrees. For all those it works. Yeah.
But in other cases that A is these three lattices are not equal.
Yeah, for trigonal it will not work. For monoclinic it will not work. For hexagonal it will not work.
Orthorhombic, sir.
Orthorhombic it will work, no? Alpha, beta, gamma equal to 90 degrees.
90 degrees.
Yes, for that.
But A is not equals to B is not equals to C, no, sir, there.
That's okay. In that case, this equation will stay. You don't have to reduce it to this. This final equation is only for cubic. For other 3 or 4, other 3, this will work. For other 4, this will not work at all. Okay.
Okay, sir. Okay, sir.
Yeah. Understood. Any doubt till this point?
No, sir.
Okay, we'll move on. Fine. So this I'll leave as it is for your reference. So then next is the coordination number. What is coordination number? Coordination number is how do you define coordination number in chemistry?
Number of
atoms.
Number of
If you don't mind, once again.
Which one?
Sir, if you don't mind, will you once again show the previous slide, sir, so that we can take a screenshot?
No, I'll share this. This one, you can take the screenshot. I'll share the whole.
Not this one, sir, the derivation.
slides every day.
You will get it. Don't worry.
Okay, sir.
Take it. No problem.
Thank you, sir.
Very good. So coordination number. Somebody was defining coordination number. It is the number of
Molecules or atoms around.
Atoms that surround one atom in a lattice.
Very good. It is defined as number of nearest neighbors directly surrounding a given atom well within a crystal. Right? Number of nearest neighbors directly surrounding a given atom. That is called the coordination number. Right. So here we will discuss this coordination number for cubic crystal. That is 3 variants in cubic crystal or 3 Bravais lattices of cubic cubic lattice. That is simple cubic, body centered cubic, and face centered cubic.
Sir.
Okay. This is cubic crystal. Okay.
Sir, can you give definition, sir, of this
definition? It is the number of nearest neighbors. Write down. It is the number of nearest neighbors directly surrounding a given atom well within a crystal.
Sir, while what you said, sir? While, after while?
Well within a crystal.
So repeat that point again.
Sorry?
Repeat that point again, sir.
Okay. It is the number of nearest neighbors directly surrounding a given atom well within a crystal.
Thank you, sir.
Okay, let's move on. So now, this is a simple cubic crystal, right? First one, this is simple cubic crystal, which contains 8 atoms in a unit cell. 8 atoms or molecules in a unit cell. So this is extended simple cubic crystal. If you consider this particular atom, right, it is surrounded by 4 atoms directly along the horizontal plane and 2 atoms, one above and one below, right? So you take any atom of the simple cubic, it is surrounded by 1, 2, 3, 4. This is on the plane, horizontal plane. Then this is the 5th one above and 6th one below. Okay, right? So in simple cubic, an atom is surrounded by how many atoms?
6 other items.
6 other atoms. So
Sir,
coordination
can you
number,
please repeat that?
in simple cubic, an atom is surrounded by 6 other atoms. So its coordination number is 6.
6.
Its coordination number is 6. Write down this. That means all these 6 atoms are at a equal distance for this atom. You go in any direction, all the 6 atoms are placed at equal distance. That is why we call it as directly surrounding neighbors. Okay. Then we have this body-centered cubic. This is the body-centered cubic. This is one at the exactly at the center of the unit cell. We have one atom, and at 8 corners we have at each of the 8 corners we have one atom. So these corners are equally distant from the center. These corners are equally distant from the center. Okay, so this atom is surrounded by 8 atoms. This is the atom we are interested in, and it is surrounded by 8 atoms which are at same distance. So coordination number of,
Sir, we should consider the center atom only, sir, in BCC.
Sorry.
In BCC, we should only consider the center atom only, sir.
You take any atom. This is how you will get. You take any atom. That is how you will get.
Sir, but if you
for
take
example,
any atom.
For example, wait. I'll tell you. For example, no. Okay, let me erase this. I'll tell you. Just give me a minute. Okay, let us consider. Okay, let us consider this atom, right? This atom. Okay.
Yes, sir.
This is not center atom, right?
Yes,
okay.
Sir.
Why?
Yes, sir.
From this atom, we have one atom here. Okay, we have one atom here. And we have one atom here. Just a minute. No, it won't come. Just a minute. I'll tell you. Okay. If you consider this atom, let's take the same atom. Let's take this atom, same atom. In this unit cell, we have this atom number 1. In the neighboring unit cell, there is one body-centered atom number 2. Okay. Below this, there is one atom.
Sir, some glitches are coming in your voice, sir.
Me clearly?
No, sir, you are not audible, sir.
Just a minute. Bad network it says. Now?
Yes, sir, it's fine.
Yeah, it is okay.
Yes, sir.
Yes, sir.
Yeah, fine.
Yes, sir.
Thank you. Okay, we'll go back here. So these four atoms, what are these four atoms? Body-centered atoms of this unit cell, body-centered atom of the neighboring unit cell, body-centered atom of the body-centered atom of the unit cell, which is right below this, and the body-centered atom of the unit cell right below. These are the four atoms. All the four are body-centered atoms of the four unit cells. Unit cell number 1, neighboring unit cell which is below this, unit cell which is below the neighboring unit cell. Clear? Any doubt?
No, sir.
Okay. Now put four unit cells. One unit cell in front of this, 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 one unit cell in front of this. Okay. There you will get exactly at the same location, at some distance in front of these 1, 2, 3, 4. You will get four more body centered or body placed atoms. What do you imagine?
Sir, how did you take the 2, sir? Second one.
The next unit cell. Wait a minute. We'll go here. I'll let rub this. Shall I rub?
Okay, sir.
Then okay. Oh, we can't take the eraser. Okay. Oh, fine. It's okay. I can't use that. Just a minute. I'll clear. I should be having one more somewhere here. Yes, I'll take this one. Okay. This is one unit cell, right? Unit cell number 1, 2, 3. Right. Here we have how many unit cells? Just count and let me know quickly. How many?
8, sir.
8.
8. Very good.
8, sir.
Very good. So let's take this unit cell and let this be the atom of our interest. Let this be the atom of our interest. We want to know the coordination number for this atom, right? For that, we have to identify atoms which are at the body center. One atom at this point, one atom at this point, one atom at this point, body center of this unit cell, another atom, this unit cell's atom here. Okay, so these atoms are exactly at the same distance from this atom. Okay, this is 1, unit cell 2, unit cell 3, and unit cell 4. Okay. Right?
Yes, sir.
There are 4 unit cells behind this atom. Do you agree? Behind the considered coordination atom, there are 4 more unit cells behind this.
Yes.
Right?
Yes, sir.
5, 6, 7, and 8. Now consider the body-centered atom of this unit cell number 5, unit cell number 6, unit cell number 7, unit cell number 8. They are also at the same distance as these represented atoms. Do you agree?
Yes, sir.
Yes, sir.
Yes, no. So what is the coordination number now?
8.
8. So yeah, whether you start from a body-centered atom or you start from any corner atom, you will get coordination number of BCC as 8. You don't have to worry about it. Clear?
Yes, sir.
Great.
Sir, if you consider the 8 unit cells, we can get the 4 only, no, sir.
8, you know, you will get 8 numbers. You see, unit cell, it is like, when you consider one unit cell, it is representation, a small block or a building block of the crystal. It has extended itself in all the 3 dimensions, right?
Sir, no,
when you are
sir,
looking for planes or
sir, you are saying nearby atoms, no, sir.
Yes,
also
nearby
considering along with BCC, also there are some corners also nearby to it, no, sir.
No, they are not nearby. They appear, but they are not nearby. They cannot be as near as these are. They cannot be as near as these are.
But in simple cubic, we have considered, no, sir.
Simple cubic is different. Body centered cubic is different. For body centered cubic, this is the smallest distance.
Okay.
This is the smallest. Okay.
Okay, sir. Thank you, sir.
Okay. For face centered, okay, what is the time? It's 2:35. Well, let's stop here. Let's continue tomorrow. Not tomorrow. Monday.
Sir.
Yes.
Sir.
You are not clear.
Sir.
Excuse me, sir.
Can you
Yes,
please
I'm
say
hearing.
that?
I'm here. You have to repeat.
Sir, I am saying that